This simulation demonstrates how we add vectors, and it allows the user to select, in this case, for example, selected this vector, and by moving the point, as I'll show in the simulation, we can change the length and the angle. Added a second vector and a third vector, and then the sum of vectors gives the result with the corresponding equation. Simulation has other options for multiplying a vector by a scalar, for a dot product and a cross product, and hopefully this simulation helps visualize the behavior of working with vectors. So let's go and look at the simulation. So here we're looking at a vector, and we can move to select the length and the angle. If we move the point over the vector, then it gives the x and the y components of the vector. Can now insert a second vector, and again can change its properties. Again, we can see the x and y components, and let's add one more. Now when I sum vectors, then the net effect of these three vectors is this one. So let's reset and look at scalar multiplication. So this says we have a vector, and it's set to start from 0, 0. And we multiply it by 2.5, then it shows the multiplied vector. So scalar multiplication means we don't change the direction, all we change is the length of the vector. So again, we can reset that. The dot product requires us to input the numerical values of two vectors we want to take the dot product. So let me pause and do that. So I've input the values, and you can see the vectors up here. Now when I calculate the dot product, it steps through the calculation and gives the value for the dot product. And then the final calculation vector is the cross product. Now we have sliders that allow us to change the values of in this case, the v vector. So, and the u vector. And now if I asked it to calculate the cross product, well, this actually goes off scale, so I can make some adjustments to change which vectors. So it shows the cross product, and this is in, of course, 3 dimensions. It tries to represent here that 3 dimensions, so this normal plane might help represent what that cross product is. But vectors show up in a number of applications, so it's good to have an understanding of their behavior and how to do these calculations.